My favorite idea in physics has always been friction. It's a simpler one, but the magnitude of its application to almost every moment of our daily life always amazes me. And my favorite thing to apply this to is skateboarding. The more I think about this, the more I think about one specific component of friction too, which is mu. What is mu? Or in other words, what is the coefficient of friction? But the coefficient of friction is exactly what I'm trying to understand. It's almost always given to us, and it has no units. So I applied this to several scenarios in skateboarding to try to understand it better and see how it affects that. Just like almost anything else, skateboarding is entirely subject to the power of friction. Sometimes there's too much friction, and sometimes, well, there's not enough friction. As you probably already know, the force of friction equals the normal force times the coefficient of friction, and if my normal force remains constant on the skateboard, then the only factor that changes and affects me in so many different ways is mu, or the coefficient of friction. For example, skateboard wheels are made of urethane for the intended coefficient of friction it has with the concrete, allowing them to grip the ground but also slightly slide to slow down and change the board's orientation. The top of the board is laid with grip tape, a sandpaper-like material that has a very high coefficient of friction between the grip tape and one's shoes so that the feet has a strong traction on the board and can drag on it to bring it up in the air. If there was no friction here, my foot would simply slide right off the board and it would get nowhere near the height needed to make it over the cone. While I've shown a few examples on how the coefficient of friction affects movement, I've still yet to define it. When it comes down to it, the coefficient of friction, or mu, is simply a value that shows the relationship between the force of friction between two objects and the normal force between the objects that are involved. So while the meaning behind mu is often overlooked, the truth is that there's not much meaning at all, other than the relationship between friction and normal force.